Hello everyone. Today we are discuss about Qpsk. Qpsk means quadrature phase shift keying. On completion of students will be able to explain the concept of Qpsk in modulation scheme and describe the operation of Qpsk transmitter and receiver. Qpsk quadrature phase shift keying has twice the bandwidth efficiency of BPSK. Two bits are modulated at once. The phase of the carrier takes on one of four equally spaced values such as 0, 5 by 2, 5 and 3 pi by 2, where each value of phase corresponds to a unique pair of message bits. The Qpsk signal for this set of symbol states may be defined as the given function. The time interval is the 0 to t and greater than t of s, where ts is the symbol duration and is equal to twice the bit period. Using trigonometric identities, the above equation can be rewritten for the interval 0 to less than or equal to t greater than or equal to ts, as the Qpsk equation is given. The function, this is the one of the basic function of Qpsk, defined over the interval 0 less than or equal to t greater than or equal to ts for the Qpsk signal set. Then the four signal in the set can be expressed in terms of the basis signal as it is the first one is the pi 1 and pi 2. The time is I is equal to 1, 2, 3, 4. The Qpsk signal can be depicted using a two-dimensional constellation diagram with 4 points as shown the below figure. And the figure another Qpsk signal set where the phase values are 5 by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. This is the first figure A, Qpsk constellation diagram. It is a 0, pi by 2, pi, 3 pi by 2. The B figure is the Qpsk constellation carrier phases are pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. From the constellation diagram of a Qpsk signal, it can be seen that the distance between adjacent points in the constellation is root 2e of b. Since each symbol corresponds to 2 bits, then E is equal to 2EB. Thus the distance between two neighboring points in the Qpsk constellation is equal to 2 root of EB. The average probability of bit error in the additive white Gaussian noise channel is obtained as P E of Qpsk is equal to Q of root 2 EB divided by N naught. The Qpsk transmitter here give the input data RB. The RB is given to serial to parallel converter. That input data separated by RB divided by 2, then sent to low pass filter. The low pass filter, it's multiply the one signal to local oscillator and phase shift to 90 degree, then give the summation, then output signal of the BPSK original BPSK band pass filter, then only output of the original QPSK signal is sent. Then the QPSK receiver, the received signal of the error signals give to the bandpass filter. This filter separate the two signals and odd and even symbol rates and carry recovery circuits. That circuit phase shift to 90 degree of the odd or even symbols. Then only low pass filter sent to the symbol timing recovery block diagram block. The symbol timing recovery block is timing of the same symbol or repeated or error symbols are repeated. We find the original symbol and decision circuit is decide it is a original bits and it is a error bits. It's decide a original bits sent to the multiplexer. The multiplexer recover all the both signal multiplexed with the recovered signal into the output. The bit error probability of QPSK is identical to BPSK, but twice as much data can be sent in the same bandwidth. Thus, when compared to BPSK, QPSK provides twice the spectral efficiency with exactly the same energy efficiency. The null to null RF bandwidth is equal to the bit rate RB, which is half that of a BPSK signal. Thank you.